Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the applications of trigonometric functions. Trigonometry can be used to solve many applied problems. Trigonometric functions have applications in the fields of science, navigation, and optics, among many others. In the next few lessons, we will study several real-life problems that can be solved using trigonometric functions. We will begin by solving triangles. Let us get started, students. We will try an example together. Here we have a right-angled triangle. One of the interior angles has a measure of 30 degrees, and the hypotenuse has a length of 8 units. The sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of the other angle is 60 degrees. To find the length of x, we use the sine of 30 degrees equals x over 8. Since the sine of 30 degrees is 1/2, x equals 4 units. Similarly, to find the length of y, we use the cosine function. The cosine of 30 degrees is the square root of 3 over 2. We use y over 8 and solve for y. The measure of y is 4 times the square root of 3. In real life, we can use trigonometric functions to find distances that might be difficult to measure. For instance, to measure the height of a tower, you can use the distance between you and the tower along with the angle of the line of sight looking up to the tower. The angle formed between your line of sight and the ground is called the angle of elevation. If you are at the top of the tower looking down, the angle formed between your line of sight and a horizontal line is called the angle of depression. Students, I would like you to try an example. Samuel is standing on the top of a cliff. He can see a boat in the ocean and would like to know how far the boat is from the bottom of the cliff. Samuel is 1.7 meters tall, and the cliff is 80 meters tall. The angle of depression from Samuel's line of sight is 60 degrees. Please calculate the distance from the bottom of the cliff to the boat, shown here as line AB.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us go through the steps together. Our first step is to draw triangle ABC. To find the length of BC, we add Samuel's height to the height of the cliff, and we get 81.7 meters. We can find the measurement of angle C by subtracting 60 from 90. Angle C measures 30 degrees. Since we are looking for the length of AB, which is opposite to angle C, and we know the length of the adjacent line, we will use the tangent function. Tangent of 30 degrees is equal to AB over 81.7. Tangent of 30 degrees is 1 over the square root of 3. When we solve for AB, we get 81.7 divided by the square root of 3. Therefore, the length of AB is 81.7 meters over the square root of 3, or 47.2 meters. Good work, students. Trigonometric functions can even be used to solve triangles that are not right-angled. Such triangles are called oblique triangles. As long as you know the measures of at least one side and any other two measures, angles or sides, you can find all the other measures. In order to solve an oblique triangle, you need the law of sines and the law of cosines. The law of sines says that in any triangle ABC, A over sine of A equals B over sine of B equals C over sine of C. In other words, the sides are proportional to the sines of the opposite angles. Students, please use the law of sines to solve this triangle. You are given 3 of the 6 measures in an angle, angle and side situation.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. Please compare your answers to these. Angle F is equal to 65 degrees. If we add together angle E and angle G and subtract this number from 180, we get 65 degrees. Side F is equal to about 33 units. We use the law of sines, which says that F over the sine of 65 degrees is equal to 35 over the sine of 75 degrees. When we solve for F, we get approximately 33 degrees. Side E is equal to about 23 units. Again, we use the law of sines, which says that E over the sine of 40 degrees is equal to 35 over the sine of 75 degrees. When we solve for E, we get approximately 23 units. The law of cosines is used when we know the measure of all three sides, but none of the angles. It is also used when we know the measure of two sides and the included angle. The law of cosines says that in any triangle ABC, A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. The same relationship is true for B and C. Let us look at an example together. We will solve triangle ABC, where A equals 12 units, C equals 28 units, and the measure of angle B is 115. We can find the length of side B by using our law of cosines. By substitution, we find that B squared equals 12 squared plus 28 squared minus 2 times 12 times 28 times the cosine of 115. B squared equals 2,632. So B equals about 51.3. Now that we have the length of all three sides and the measure of one of the interior angles, we can use the law of sines. We will solve for angle A by using our values for B. 12 over the sine of A is equal to 51.3 over the sine of 115. Angle A measures about 12 degrees. Now it is easy to find the measure of angle C. We subtract 115 and 12 from 180 degrees and find that the measure of angle C is 53 degrees. We have solved the triangle. Students, Today, we have learned how to solve right angle and oblique triangles using trigonometric functions. We have seen one way that trigonometry can help us to solve a real-life problem. See if you can think of any occupations that might use trigonometry to measure heights and distances. Until next time, thank you, teacher. Thank you, students.